This exercise we're going to draw a couple of histograms. Now, a histogram is just a special type of bar chart. There are some important considerations we have to take into account. When you're drawing it, we always put the score along here and the frequency up the side. Now here we're looking at the contents of 40 packets of jelly beans. So there were 3 packs that had a contents of 78, 6 packs that had a contents of 79. So our scores are the number of jelly beans in each pack. Now this is ungrouped data. Now if the data is ungrouped, see we're just looking at packs that had 78 in here. It wasn't as if they were packs that had between 75 and 80, 78, 79, 80. Ungrouped data, and the score goes in the centre of each column. 78, 79, 80, up to 84. Don't think it was a good idea to label that scores. I think it would be better just to label it number of jelly beans per pack. Or just jelly beans will do. And so there were 3 packs that had 78 jelly beans, so I want this to go up to 3. Better check our axes. I want to have a maximum of 10. So 0, 1, 2, 3, 4, 5. I'll do it to 10. I'm not doing a very good job of this, am I? So I want the first column to go up to 3. So, and a really important feature of histograms is there's never any gaps left between your columns. The next one goes up to 6. Up to 8. Now there were 10 packs that had 81 jelly beans in them. 10 is there. Eight packs had 82 jelly beans in them. Three packs had 83, and 2 packs had 84. Okay, so remember those important points. I'm going to colour that in and finish it off in a second. When you colour it all one column. These columns are essentially representing the same thing, so all one colour when you're doing a histogram. Don't leave gaps between the columns. And if we're dealing with ungrouped data, like this, put your scores under the centre of each column. I'm going to finish that one in just a moment, and I'll pause and then I'll come back and we'll have a look at the second one. Okay, we're going to come back and have a look at that first graph in just a minute again too, but let's start work on the second graph, and we're going to draw a histogram here too, but first some questions. What we've got is a forester who's measuring the circumference or girth of 25 trees in a plantation. These are his results. We're asked what type of data it is. Well, these are the results he's got are numbers, so it's obviously numerical data. He was making measurements, and when you make measurements, that'll often result in continuous data. These are whole numbers, all his measurements, but it would have been possible that he could have had a tree that measured 90.5 centimetres in circumference, or even 90.542. You know, if he was had very accurate measuring instruments, it's definitely continuous data. So I'm saying it's numerical, continuous data. we need to tally the data. So one by one we need to go through. Oh, and it says a group size of 5. We need to decide how we're going to do our groups. It looks to me like the smallest piece of data here is 81. I don't think we've got any in the 70s. So we'll make our first group go up to from 80 up to all the way up to 85, but not including 85. Now there are a number of ways you can actually write that. You could just write 80 dash, and then the next group 85 dash. That would mean 80 and all the way up to 85, not including 85. I want to avoid the situation where I have 80 up to 84, 85 up to 89. I don't really like that because it kind of indicates there's a gap in between the columns here, and that's not the case with continuous data. I think I'll write this one 80 up to 85, but not including, not equal to 85. 85 up to 90, but not actually equaling 90. 90 up to 95, but not equaling 95. See, this removes the ambiguity of if there was one exactly equaling 90, it would go in this group, not in this group. This group is 85 all the way up to 90, but not including. 95 to 100, but not 100. That goes in the next group. And the next group is 100 up to 105, but not actually equaling 105. Okay, I think that should do it. Let's tally the data. So the first one is 102, goes in this group. 95, it doesn't go in this one because this is 90 to 95, but not equaling 95. That would go in that group. 88 goes in this group. 96 goes in this group. 104, 81, 90, 94, 92, 101, 99, 83, 88, Okay, hope I've got it. Let's see, we've got 2, 3, 6, 8 and 6, all up 25. We were supposed to have 25, so that's looking pretty good. I hope I've put them all in the right places. Now, this time where we're dealing with grouped data and we've got a continuous scale, what we're going to do is put the numbers under the edges of each column. So here we've got the girth or circumference measured in centimetres, and I'm going to put them under the edges of the column. So it's going to be, I'm going to build a column from 80 up to 85, 90, 95, 100, 105. So my first column is going to go between here and here. And my columns have to go up to, the biggest number is 8, so we'll go 1, 2, 4, 6, 8. These are frequencies. And the first one goes up 2. The next one goes up to 3. Next one goes up to 6. We've got 8. There we've got our histogram. We have to describe the distribution of the data. Notice the shape of this histogram. It's not balanced. This is what we call a skewed histogram. And this one we'd say is skewed to the left. Now the direction of the skew, it depends on the direction of the tail. So this one is skewed to the left, this tail out is occurring to the left. Okay, now just a couple of important points. I'm going to colour this one in and finish it off in a minute. But the important point here that I wanted you to see is if the data is grouped, then the numbers go under the edges of the columns. As opposed to what we had before. And if I just move this down, we had individual data here. This wasn't a group of data, and we put the numbers under the centres of the columns. Okay, you need to get some practice doing some histogram, so have a go at some from the back of the book.